Here we have a SAT math problem. Okay, let's go to the question. There is a figure given over here. In the figure above, E and F are the midpoints of two sides of a rectangle. If the area of triangle CEF is 10, what is the area of the shaded region? Okay, so my idea to solve this problem is first to get the area of this triangle CBD, the bigger triangle over here. Once I get the area of this triangle CBD, I can subtract the area of the triangle CEF, which is given in the question, that is 10. When I subtract the area of this triangle from this triangle CBD, I'll be able to get the area of the shaded region. So now my aim is to get the area of the bigger triangle CBD. Okay, now let me consider the given information. The question says E and F are the midpoints of the two sides of the rectangle. That is, E is the midpoint of the side BC over here, and F is the midpoint of the CD over here. Since E and F are the midpoints of CB and CD, EF is the mid segment of the triangle CBD. In any triangle, the mid segment is always parallel to one of the sides of the triangle. In this case, this mid segment EF is parallel to the side BD of the triangle CBD. And this BC become transversal because these two lines are parallel. EF and BD are two parallel line segments. BC is a transversal. Since BC is a transversal and these two are parallel line segments, the angle measure over here and angle measure over here are corresponding angles, and they are congruent. And now we can consider the angle measure over here at C, at the vertex C. Now we can consider two triangles, the smaller triangle CEF and the bigger triangle CBD. In these two triangles, the two angle measures of the smaller triangle are congruent to the two angle measures of the bigger triangle, because C is a common angle for both the smaller triangle and bigger triangle. And so the two angle measure C, angle measure E of the smaller triangle are congruent to angle measure C and angle measure B of the bigger triangle. Since the two angle measures of one triangle are congruent to two angle measures of another triangle, then the two triangles are said to be similar by angle similarity postulate. Okay, now let me write the vertices in order. First, let me take the vertex C in the smaller triangle. Okay, what is the corresponding vertex in the bigger triangle CBD? The same C, because C is a common vertex for both the triangles. Now let me consider the vertex E in the smaller triangle. What is the corresponding vertex in the bigger triangle? That is B, because the angle measure over here and angle measure over here are equal. They are corresponding angles. So the corresponding vertex in the bigger triangle is B. Now let me take the third vertex of the smaller triangle, that is F, and the third vertex in the bigger triangle is D. So these two triangles are similar by angle similarity postulate. Okay, already we know that E is the midpoint of the line segment CB. For example, I assume the length of the line segment EC is just 1. What is the length of the line segment B? That is also 1, because E is the midpoint. Midpoint means it divides this line segment BC into two equal parts. Okay, what is the length of this line segment CB? That is 2, because 1 positive 1 is 2. Okay, now let's consider the lengths of the corresponding sides of these two similar triangles. Let me take the side covered by these two letters CE. What is the length of CE? That is 1. And what the corresponding side in the second triangle is CB, because here in the first triangle I consider the letters at the first portion and second portion. To get the corresponding side, we have to consider the letters at the same portion CB. What is the length of the side CB? That is 2. So now let's consider this important point. Two triangles are similar and the lengths of the corresponding sides are in the ratio 1 to 2. Okay, if the lengths of the corresponding sides are in the ratio 1 to 2, then what is the ratio of the areas of these two similar triangles? So that's very simple. What we have to do is we have to square these two numbers. Then I'm getting 1 square to 2 square. Then I'm getting 1 to 4. So the areas of these two similar triangles are in the ratio 1 to 4. Already we know the area of the smaller triangle CEF, that is 10. Okay, let me write the stuff over here. Area of the smaller triangle CEF is given in the question itself, that is 10. Okay, now let me assume that the area of the bigger triangle CBD as just X. Okay, now I have the areas of both the triangles CEF and CBD. So what is the ratio of the areas of these two triangles? First, let me write the area of the smaller triangle 10, and now let me write the area of the bigger triangle X. So this is the ratio of the areas of two similar triangles over here. Okay, already we have the ratio of the areas of two similar triangles over here 1 to 4. That is ratio between the area of the smaller triangle and bigger triangle. So the same ratio we have over here. That is a ratio between the area of the smaller triangle and bigger triangle. Both the ratios represent the same stuff. There is a ratio of the areas of two similar triangles. Since both the ratios represent the same stuff, we can equate them. That is 10 to x equals to 1 to 4. Okay, now what we have to do is we have to solve for x in this equation, which represents the area of the bigger triangle CBD. For that, we have to write each of these two ratios as fractions. Okay, let me write them as fractions. Then I'm getting 10 over x equals to 1 to 4 can be written as a fraction, that is 1 over 4. Okay, now we can do cross multiplication. When I do so, this 10 has to be multiplied by this denominator 4. Then I'm getting 10 times 4 equals to, and this x and 1 has have to be multiplied, that is x times 1. 10 times 4 is 40, and x times 1 is just x. Okay, now I got the area of the bigger triangle CBD, that is 40. Okay, now what we have to do is we have to subtract the area of the smaller triangle over here from the area of the bigger triangle CBD, so that I'll be getting the area of the shaded region. So required area is nothing but the area of the shaded region is equal to, first I have to write the area of the bigger triangle CBD, which is 40, negative area of the smaller triangle, that is 10. When I subtract 10 from 40, I'm getting 30. Therefore, the area of this shaded region is 30. We find 30 in answer choice D. The correct answer choice for this question is D.